All right. I think we're going to go ahead and get started, everyone. This session, as it says up there, is powering your CSS with Lightning design tokens. Hopefully you're in the right session, because that's what we're going to talk about today. I'm Chase Logan. I'm a senior software engineer for Presence Product Group. They're an awesome company right up Market Street that has helped get me to this point today. And we're a team full of some really talented folks that can help see any idea from concept to completion. So stop by, say hello, bring your ping pong paddle. We take that part pretty seriously. Moving right along, forward-looking statements. It used to be called Safe Harbor. Even if this is your first Dreamforce, you've probably seen this 10 times already. Very quickly, Salesforce is a publicly traded company. Make your purchasing decisions on what is commercially available. I don't think we need to spend any more time on that. So before we dive straight into the tech stuff, I wanted to give just a quick minute, let you know who you're talking to today, a bit of background about myself. Professionally, as I said earlier, my name is Chase Logan. I'm a senior engineer. Been in the field about 7 years, writing in C#.NET, Java, a million JavaScript frameworks, and moving into Salesforce development about 5 years ago. In my free time, I'm an Android developer and platform geek, so cheers to any fellow Android devs in the audience. Personally, as you can see up there, I fancy myself somewhat of an amateur musician. I've been playing guitar most of my life. They've been known to spontaneously combust in my presence. I'm an avid trail runner and Tough Mudder veteran. Hoorah to any fellow mudders in the audience. And I'm here today because I'm passionate about technology and the Salesforce platform, learning, expanding my own knowledge, and hopefully being able to share that with a wider audience. So before we get too far into it, let's take a look at an overview. What are we talking about today? What are we here to learn about? Asked me to set up this next slide. So outline. To make sure everyone is on the same page with at least a basic understanding, we're going to cover Lightning components and the Lightning component framework. Think of it as a crash course introduction to both of those topics. We'll take a look at Lightning component bundles and why they're important. That's a screenshot from the dev console of a Lightning component bundle right up there. And then we'll take a look at some considerations for your Lightning components CSS. We'll also take a look at how those considerations, if I can get there, how those considerations tie into CSS reusability and using Lightning design tokens. And we'll finish all of that off with a live demo of some code in action. And then we will leave about 10 minutes at the end of the session for Q&A, so if I can ask that we hold any questions until then. We've got a ton to cover in this session and not a whole lot of time to do it. So we will do all of that in an effort to answer the question, how do I handle low-level CSS reusability across my component library? So before we answer that question, I've got a couple of questions for the audience. How many of you, show of hands, are familiar with the Lightning component framework? Hands? Awesome. Looks like most of you. For those of you who raised your hand, how many of you have built your own custom Lightning components? Perfect. Awesome. OK, so for those of you who raised your hand to either question, these next couple of slides are going to be a bit of review. For everyone else, think of this as your crash course intro to both of them. The Lightning component framework, Lightning components. Lightning components are built and run on the Lightning component framework, which itself is a modern framework for building single-page applications. The components themselves, they're flexible, reusable, self-contained units within an app. Think your own little Lego block. Components can range in scale from something as simple as a single line of text all the way up to housing an entire application. The framework itself includes many pre-built components. Think input text boxes, pick lists, date widgets, all of that stuff. Or you can build your own Lightning components from scratch. And in the demo, that's what we're going to be taking a look at in a little bit. You can see in this crudely put together screenshot there a container of a top-level app with multiple components in it, pre-built components, nested components. Components can actually contain other components. You can nest components together to form new components. And lastly, your components get rendered by the framework to produce the HTML DOM elements that we all know and love in the browser. Take a drink real quick here. So that being said, I want to spend just a second longer talking about Lightning components in detail. Lightning components, at their core, Components are designed with encapsulation in mind. Your little Lego contains all that it needs to describe itself as a Lego block. This frees your consumers, and by consumers, I mean the apps implementing your components, from any tight coupling to the actual implementation of the component. And likewise, it frees the component authors, all of you bright individuals out there, from any type of coupling or concern with the outside application. Your little Lego block doesn't have to care about the rest of the Lego tower, the rest of the Lego Millennium Falcon you're building, because it has everything it needs to describe itself as a Lego block. So it's an important part of Lightning Components, that encapsulation, and I just wanted to touch on it to make sure everyone has a solid understanding. So I know we've covered quite a bit there in a couple of minutes. We've touched on Lightning Components and the component framework, and we've reiterated that power of encapsulation that comes with each component. So a component bundle then, what is a Lightning component bundle? Why do I have to care about that? The Lightning component bundle is actually what drives that power of encapsulation that we've discussed on the last couple of slides. Is a screenshot from the dev console of what a Lightning component bundle looks like. Lightning component bundles, they essentially provide the scaffolding for which your component is built on. Every Lightning component or app has its own component bundle. It's a one-to-one relationship, one component or app per bundle. You can see here in this screenshot straight from the dev console that a component bundle includes everything to make your component, your little Lego block, its own encapsulated unit. It has the styles, all necessary client-side renderer, helper, and controller JavaScript. Even design, icon, and documentation resources. Everything your component needs to describe itself as that Jenga block. This is a similar approach to many modern frameworks like React, but it's engineered natively for the platform via metadata. For the purposes of this presentation today, it's important to note that style resource. This is where you apply your component CSS, and it's part of every single component bundle. So, touching on that same topic, CSS considerations. So far, we've highlighted that self-contained power that component bundles give us. But what kind of effect does that have on our CSS? What type of considerations do we need to take into account when we're styling our components? I ask yet again to set up the next slide. So, keeping that same encapsulation principle in mind, and I'm repeating this often because it's important, any component, no matter the size, should be styled locally from within the component bundle. This frees both the component author and the component consumer that we talked about a couple slides back from worrying about including some random style sheet or JavaScript reference at the top level application for a component all the way down the tree, all the way down your Lego Millennium Falcon. Your components contain their own local styles, everything they need to be their own little encapsulated Lego block. So, that was a quick crash course introduction. We covered a lot of information in 8 minutes. What does that mean? I mean, so far, we've talked about the framework, Lightning components in their bundles. Hopefully everyone's ready. Hopefully you're all with me. We've got compartmentalized components encapsulated with their own markup, styles, and client-side code. I'm ready to do this thing. I'm ready to put all of the components in my app. But hang on a second, wait just a minute. Some of you might be wondering or asking the question, and maybe those with a tad more experience using Lightning components, what about my boilerplate CSS? What about the low-level styles that I apply to literally everything in my app? The font families and color hex values, the pixel values for margins and spacing, even the common box shadow that I slap on everything because I love box shadows. You're telling me that I have to repeat that redundant low-level code across all of my components and all of my apps? I have possibly hundreds of components in my component library. That seems like a lot of redundant, unmaintainable, low-level CSS. Well, that's a good question. Yet again, setting up the next slide, and thankfully answering it is why we're here today. How do we solve for the problem? How do I handle low-level CSS reuse across my component library? There's got to be a better way. What does Salesforce say about this? What does Salesforce suggest to tackle this problem? Well, you've got a couple of different approaches. Taking a look at our first option here. Lightning components do support external CSS entities loaded as static resources the same way you would via an Apex style sheet tag in any Visualforce page or component by using the lightning require tag. There is nothing wrong with the lightning require tag. You're going to have to use it at some point in time. Simply put, for the purposes of this solution, solving CSS duplication, it's not the best approach, and there's a couple of caveats, there's a couple of reasons why. You have to include that lightning require tag in every component. If we're keeping that concept of encapsulation in mind, where every component is its own Lego block, it should look the same, it should feel the same no matter where it's used, we need to include that lightning require tag in every component. If you've got hundreds of components, that's hundreds of lines of including a static resource. What if that static resource name changes? Now you've got to go update all of those components. It's maintenance work that you have to do to remember to include that lightning require tag. It does solve for CSS reuse across multiple components. If you've got some base style sheets with some base classes, you can use it across your components with this approach. It solves for that. It does not solve for many similar or identical low-level values in the same style sheets. If you've got default values for margin, padding, spacing, etc., across multiple classes in the same style sheet, this approach is not going to solve for that. But thankfully, the star of today's session, Lightning Design Tokens. There is a better way. Lightning Design Tokens do not require any Lightning require tag references. They're not necessary to use Lightning Design Tokens. It solves for many similar or identical low-level CSS values in the same style sheet. It also solves for CSS reuse not only across multiple components, but across multiple apps in your component library, which we'll see in the demo in just a little bit. So it's all well and good. It's good information. It's good to know. But what is a Lightning Design Token? The name of this session, Power Your CSS with Lightning Design Tokens. That's what we're really here to learn about, hopefully. So what are they? Lightning Design Tokens. What is a design token? Tokens are, at their simplest, just a named entity that's accessible from across your component library. They're visual design atoms. All that means is name-value pair. That's what it boils down to at its most simplest. That's all a Lightning Design Token is. Fortunately, they're a type of bundle, just like components. And that's important because it means they can be deployed by themselves. The first and default bundle is called default tokens. And in a very Salesforcean way, you don't even have an option of changing the name of that default bundle. It's always default tokens the first time you create one. The good thing about that is any token defined inside of default tokens is immediately accessible across every component, every app in your namespace, in your library. It's instantly accessible, it's there, it's ready for you to use. Again, good information, but let's take a quick example at some implementation of how we would actually implement a design token. I've got a couple of screenshots up there. As I said before, they're just that name-value pair. That's what they boil down to. Tokens resolve to a single value that can be used the same way you would use a valid value in any style sheet. Think background color hex value, font families and sizing, margin and spacing pixel values, all of that stuff. These named entities can then be referenced directly in your CSS using the nifty token function. Shown here shortened to the letter T. Both the word token and the letter T are semantically identical and resolve to the same function. So long as you're using meaningfully named tokens, one is not better than the other. I prefer T for its succinctness. Use whatever you choose. You can see in the top screenshot, I've defined a simple token inside of default tokens called default body background color. I can read the name of that token and have a pretty good idea of what it's doing. I can see the value is assigned to white, all Fs, F, 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 F. It resolves to the color white. And then in the snippet below, I've got a class from one of my component's CSS resources. And the first property in that class is this background color. And I'm assigning it to that token I just defined using the token function and passing in the name of the token, default body background color. It is as simple as that. As soon as you define and save the token, you can reference them in your component CSS just like that. It's the same thing as if I had hard-coded that FFFFF value for background color. And that's really it. That's all there is to it. If that doesn't make sense yet, Fret not, because we're going to dive into a demo. We're going to take a look at a couple of things. We're going to look at a simple little weather app I put together, mostly for the sake of teaching myself more about Lightning components and Lightning design tokens. We'll see, we'll poke through the CSS. We'll take a very quick look, because of time, at the client-side and backend controller code. And then we'll see Lightning design tokens in action. We'll see how easy it is to manage boilerplate CSS, not only across multiple components, but also across multiple apps in our component library. So, fingers crossed. Oh, knocked my water over. Fingers crossed that the internet works. A live demo at Dreamforce. What could go wrong? Let's see here. So, hopefully you guys can see this. On the left there, can you guys see that? Do I need to blow it up further? Good. So, I guess all the way on the right, this is the MyWeather standalone Lightning app. This is a weather app built with Lightning components. Everything you're seeing there, I have the Chrome Dev Console set to look like a Nexus 6P. That's my phone. I built the app for my phone for mobile devices. It looks best on a mobile device. It's responsive, but that's how I'm showing it to you. Everything you're seeing there on the screen is part of the MyWeather Lightning app, the container. And what I want to point out before we dive into the code is that from the Weather Underground logo at the top, and this app is built on the Weather Underground RESTful API, so as a terms of use, I must include that logo. From the logo at the top to the current conditions beneath that, to the 3-day outlook, and to the animated zoomable radar beneath that, everything you're seeing there is its own individual Lightning component, their own little Lego blocks. And this gives a better visual representation of how those Lego blocks stack together to form your Millennium Falcon Lego of an app, your complete whole app that you're seeing there on the screen. The other thing I want to point out before we dive into the code is that everything you're seeing here is also styled by the SLDS. What is the SLDS? It's the Salesforce Lightning Design System. Essentially what that is, it's just a CSS framework. It's built on Flexbox, so it's super easy to use, and it's meant to give you stock look and feel of Lightning out of the box. So if you're building custom Lightning components and you want them to have stock look and feel, you can use the SLDS to achieve that. I chose the SLDS for that reason, and because it's easy to use with Flexbox. There is no requirement to using the SLDS for Lightning design tokens or for building Lightning components. It's just what I chose for this app. So, as I mentioned, everything you're seeing on the screen there, you can see in the address bar, it's part of the MyWeather app container. If we look at dive in to the actual code, if my computer will play nice, maybe not. All right. If we dive into the actual MyWeather app, there's only 3 lines of markup there. There's the top-level Aura application tag, and then you can see there's a current weather component. Basically, everything you're seeing on the screen here is part of the current weather component. It's a nested component inside of a component, and that's all that it is. If we take a look at the current weather component, we can see I've got my Lightning component bundle on the right here. I've got my component markup, my JavaScript controller and helper classes, and my style resource. If we look at this entire bit of markup, there's only 174 lines there. There's only 174 lines because most of this component is made of other nested components. From the logo at the top that you can see there, if I look here, current weather logo is its own, play nice, there we go. Weather logo is its own component. It exposes attributes for height and width, and that's all I need to care about. That's all the consumer needs to care about. I populate those attributes. Whatever else is going on in that weather logo component, I don't have to care. I don't have to care about that implementation. Likewise, from the current conditions, the 3-day outlook, the zoomable animated radar, every one of those is its own individual separate component, its own little Lego block that exposes a couple of attributes saying, these are the attributes I need to function. This is what I need for me to work, for me to display data. I'm populating those attributes, and that's all I have to care about. Those attributes act sort of like a contract between consumer and author that this is all I need to care about. How that component handles its implementation is not up to me, and I do not care. I could spend an entire session talking just about component design and interactions with client and server side. But unfortunately, that's not the star of today's show, so we do have to do a kind of brief overview. The other thing I do want to point out before we dive into the tokens, at the top here of current weather component, we can see we've got controller, current weather controller. That works exactly like it does in Visualforce, and that is actually pointing to a server-side Apex controller called Current Weather Controller. It works a little bit differently in Lightning in that we've also got an additional layer of client-side functionality, including a client-side controller. In Lightning, your server-side controller mainly handles the heavy lifting of web service calls, database access, object lookup, and then it passes those results back to the client-side controller to handle the interactions with the view. The client-side controller takes on the meat of that work. We can see, looking at my client-side controller for the current weather component, there's a function here called init page, and that's doing exactly what it sounds like. When this component is first loaded, when it's initialized, it's doing a couple of really simple things. It's looking for a session cookie. If you've been to the site before, if I refresh this page, it's going to pull up my session out of my browser so that it can load the same location I was just viewing. It's going to check and see whether or not that session was stale and request new data via web service, if that's the case. But all of that is happening here in this server init weather details. That is a client or a server-side Apex method called server init weather details. And if any of you have ever done anything with Visualforce remoting, this works very similarly, where I'm making a function, I'm setting a callback, and the callback is handling the result of that server-side method. So the server-side method fires, whatever happens inside of it, the callback fires after that's completed, and then the callback is actually handling the interaction with the view. It's hiding or showing components. It's initializing the view based on whatever that server-side call did. Very quickly again, we'll take a look at the server-side controller in my editor, and hopefully you guys can see that. I've got a method here inside current weather controller called server init weather details. That's the method I'm calling inside that component. We can see here it's got the annotation for Aura enabled. This works very similarly to the remote action annotation for remoting methods. It must be there in order for you. That basically says this method is available for the Lightning component framework to communicate with. And it's doing very little work. It's accepting a session ID. If that session ID exists in the database, it's pulling some cached data out of the database. And if that data is stale, it's making a web service call to go get new data. If it doesn't have any data, it's just returning that, bubbling it back to the client-side controller, letting the client-side controller manage what happens in the view based off this very simple implementation. That's how most of these methods work. All of this code is already on my GitHub. It will be posted at the end of the presentation. For you, feel free to clone it, download it, do whatever you want. But we do need to move on to Lightning design tokens in order for us to finish this presentation and talk about the star of the show. So, moving back to my dev console, let's take a look at my default tokens bundle here. As I mentioned earlier, default tokens is the name of the default bundle that gets created for Lightning design tokens. I have several tokens defined here, and they all define default low-level reusable values that I could use across my entire component library. I've got things like atmosphere, which is really just a box shadow. I've got a default atmosphere. My buttons have a slightly different atmosphere, and my inputs have a slightly different atmosphere. But all of my buttons and all of my inputs share the same atmosphere. Likewise for background color, body background, margin, top, bottom, left, padding, you get it. All very low-level, reusable default values that I might need to use across many components in my library. I'm defining their values once here and giving them a name so that I can use them wherever I want to use them in my component library. If we take a look at the CSS for current weather, the CSS resource, we've got a couple of classes defined there. One of them, this main base div default, is this pretty blue background you're seeing there in the app. Hopefully you can still see that. The blue background you're seeing is part of that. I'm setting background color using a token. I'm setting that background color using the token function to default background color, resolves to that pretty blue. Also, we can see top and left here, default top, default left. I'm using those values in multiple classes in the same CSS resource, and I'm not hard coding them. I'm setting them to a token value, so if they change in the future, I don't have to change them in multiple classes here. I change them in one place. The other thing I want to show you is my happy hour tracker app. This is Dreamforce, right? Everybody likes happy hour. We've got a couple of happy hours defined there. This is just a static app, static content that I threw together for the purposes of this demo. But you can see there's something very similar there. It's got the same base blue, pretty blue background. It's got the same white foreground. Think of that as my template. I reuse this template for multiple of my own personal apps. If you're a corporate organization or a large organization, maybe you have many distinct apps that do their own specific purpose, but you want them all to have a similar look and feel. You can accomplish that very easily using design tokens. You get that look and feel for free. What I want to go into next, I can show you real quick. So the point of all of that, the main advantage of design tokens, maintenance, changes. Changes always happen. One thing, it's one thing today, it's another thing tomorrow. This is what my app looks like now, but let's say your product owner, your product manager, your business users, your boss, whoever it is, they come to you and they say, I'm tired of this blue background. I'm tired of these subtle box shadows on these buttons. We're changing them. We need to really make it pop, and we're going to change it across all of our applications, all of our components, and I want it done as soon as possible. Had you not designed with Lightning design tokens in mind, that's a lot of individual changes you're going to have to make across possibly hundreds of components. You're going to have to test them, and then you're going to have to redeploy all of them. But because we went with Lightning design tokens in mind, and keep in mind everything you're seeing in that app there, all of the buttons, they're all their own individual components, their own Lightning components. I'm going to do a quick demo where I make that change. And I've got a couple of commented out values already to help me out for this demo, but I'm going to change the button atmosphere, and I'm going to change the background color just to show how easy it is to make that change with design tokens. So I'm going to uncomment our new color, comment out the old atmosphere. If I can get it to play nice, there we go. And likewise, I'm going to change the background color to the new background color, and these colors are really going to make things pop. This is what everyone wanted. I saved my default tokens bundle. I have made no changes anywhere else to any other components, to any of my apps. I've changed that one place and nothing else. I'm going to go back, and I'm going to refresh my weather app. Bam, Christmas colors. We got that bright red background, and we've got all of our buttons have that very subtle green box shadow. And it's applied across all of my components. Everywhere I'm using those buttons, everywhere I'm defining that box shadow token, I'm using it across multiple components. They were all instantly updated. Likewise, my separate happy hour tracker app, I'm going to refresh that. Pretty red background, green box shadow on that button. I made the change in one place. I deploy default tokens bundle up to production. That's all I have to do. I don't have to touch any of my other components. I don't have to do anything else there. I make the one change, and it's ready to go. So hopefully that illustrates the power of Lightning design tokens for managing your reusable low-level CSS. I am running short on time and about done, but we've got a couple of housekeeping items before we finish. Resources. If I were you, I would want to know where I can get this stuff, how I can teach myself more. All of this is going to be posted to the Dreamforce chatter feed in the app, as well as I'm going to be posting it on my Twitter after the presentation, so you guys can grab this. This is everything I used to build those apps, to teach myself, as well as all of the source code from both of those apps in the demo. It's already on my GitHub. I will be posting it to the Dreamforce chatter feed. Connect with me on Twitter, at @semiclogan. I'll be posting a direct link to my GitHub repo, as well as the Dreamforce chatter feed. And lastly, check us out, presencepg.com. Yeah, give us a shout. So that is it. You might have questions. I might have answers. So anyone? Questions? Yeah. Yeah, if you can get to it.
Are these used for anything other than CSS values? Or just value, so like less, right? For example, you can kind of use a little bit of JavaScript. Is there any of that functionality, or? Not
currently. So it's purely for lower, it's meant purely for lower level CSS value management. So if you've got like reusable values that you might have in several base classes, or things that you're doing you're seeing yourself do over and over, this is meant to help speed up that process. But it's just for CSS values.
So it's only referenceable in style sheets?
Yes. Okay. It's only referenceable. Yes, correct.
Okay, perfect. Thank you.
So the question I have is, when you start designing your systems or the themes of your application, you need to define the tokens first, because sometimes what happens is you go back and add new CSS stuff. So
Yep.
if you develop the components before you create those tokens, then you have to go back again, modify those each components and add those CSS token values, default token values there. So
Yep.
I just trying to understand. So the process of developing a standardized CSS is basically create all the token first before even diving into any components. Or is there a way, like, you come across that you have to, like, scale up, like, you add something else during your process? How do you manage that?
So I think the idea is when you're starting in the design process, if you have an idea of what your low-level styles are going to look like, what your sort of base design is going to look like, if you can put those into tokens to start with, then it's available anywhere you want to use them, so any app that you're going to build. But I think it's an iterative process, and like you said, as you build new functionality, you'll probably have to go back and add new tokens. But as soon as you add them, you update your CSS and they're instantly accessible. I think trying to start with that design in mind first, having an idea of what the base design looks like, creating the tokens will help speed the process, though.
Okay, thank you.
Yep.
Are tokens only like org-wide, or can you define them from like a certain component level down?
They're-
Like, say you have subcomponents, for example.
They're namespace wide, but you can also define individual tokens. So I only showed the default tokens bundle. You can also create new tokens bundles, and if you don't put them inside of so if you create a new token bundle, you can put it inside of default tokens. You can reference it as its own bundle, and it's accessible across your namespace. If you don't do that, you can define exactly where that token bundle is referenceable, basically. So you could isolate it to an app if you wanted to by creating a bundle for that app.
Where in the interface do you define that?
You just create a new token bundle. So once default tokens is defined, it gives you the options to create a new bundle.
And when you create the new bundle, you can associate it to specific components?
You can associate it with specific apps, is my understanding.
apps.
Yeah, so that's my, so if you don't reference that new bundle that you've created in default tokens, then you control where those tokens are referenceable, basically. So that's my understanding anyway.
All right, thanks.
Yep.
Hi. So CSS variables are coming. How are these better than the native CSS variables? I suppose the deployment is
So,
easier, or maybe namespacing?
Namespacing, I think it's also just something that's more native built into the platform. So if you're doing native Lightning component development, if you're not using external, like if you're not using React, Angular, Bootstrap, you're not using external JS or CSS libraries, and you're building with sort of stock Lightning from the ground up and you're creating your own CSS, this is a built-in way, part of the platform, to make those lower level values more manageable. And it has its own pre-built bundle, which means you can deploy them by themselves. So I think it's just a slightly easier way to manage it natively on the platform. And that's probably the only advantage.
Okay, thank you.
Yep. Questions? Yep.
Is there a way to make those configurable? So if you have an app that you're putting on the App Store or something, that someone can define the colors through the tokens?
I don't think so, because I think the bundle has to be, at least I'm not sure. Yeah, because I think the bundle has to be predefined and compiled as a bundle, so I don't think you can do it at runtime. Yep. So you might be able to. Yeah, good to know.
Hi. We were looking into a white labeling solution. Have you guys used design tokens for white labeling?
Who's not?
No?
No.
Okay. I guess my follow-up question is, can you have nested tokens?
I think you can. That's a good question. I'd have to double check. I can get back to you on it. I'm pretty sure from the documentation, so it's not nested. You can do concatenations using the plus symbol. So you can combine token values using the plus symbol when you're referencing the token function. I don't know that that's really nested, but it's a sort of similar functionality. All right, cool. Thanks, everyone. Appreciate it.